Today we are going to talk about something called the Pythagorean identity. And the Pythagorean identity says that sine squared of an angle plus cosine squared of an angle is equal to 1. Now, the reason why this is called the Pythagorean identity is because it actually stems from the Pythagorean theorem. So in the last lesson, we looked at this unit circle where we said if we have a radius of 1, then a point on the unit circle is cosine, comma, sine. Well, if we make this into a right triangle, then the x is the cosine, I'm just going to call it C. The y is the sine, so let's call it S. And then that hypotenuse is 1 because that's what the radius of the circle is. And so then when we do the Pythagorean theorem, we would get sine squared plus cosine squared equals 1 squared, or 1. Okay? So let's go ahead and look at some problems that we could solve with this. So in your problems, you're going to have a problem that's going to say something like an angle in quadrant IV has sine of that angle as -4/5. And it's going to say then find the cosine of that angle. And that's what we want to solve for. Okay, so to do this, we're going to draw a picture. So in this picture, I want to draw an angle in quadrant IV. That's quadrant 4. The way the quadrants are named is 1, 2, 3, 4. It goes around counterclockwise, just like the way that we drew angles in our last lesson. So in our last lesson, we drew our angles in a counterclockwise direction. So same thing with the quadrants. They go in a counterclockwise direction. So I have an angle that is in quadrant 4. So I'm going to draw an angle in quadrant 4. Whoop. I don't know exactly how big that angle is. I'm not worrying about drawing this to scale, but I'm just going to draw that angle in there, and we always connect to our x-axis. Always connect to our x-axis. So I connect to my x-axis, and that finds my angle. Then I'm going to call that theta on the inside. It always goes next to the origin, always next to the x-axis. Now sine, when we do SOHCAHTOA, sine is opposite over hypotenuse. So that means that the opposite side in this triangle must be -4, and the hypotenuse side in this triangle must be 5. So what we want to find is then how big is the x side in this triangle? Well, x squared plus -4 in parentheses squared should equal 5 squared. Okay, so I'm going to say x squared plus 16 is 25. So x squared must be 9 if I subtract 16 from both sides. So x must be 3. So that side is 3. But 3 is not my answer because it didn't say find the missing side. It said find the cosine of the angle. Well, cosine, so COHCAHTOA, that's adjacent over hypotenuse. So the adjacent, well, that was 3. And the hypotenuse is 5. So 3/5 must be the cosine of that angle. Okay, let's try another one. So in this one, let's say that we have an angle in quadrant 2, and sine is equal to 12 over 13. Find cosine of the angle. All right, so let's draw our picture. So quadrant 2 Go around counterclockwise. So this is 1, this is 2, so my angle's somewhere in there. Always connect to the x-axis. Theta goes next to the origin. Sine is opposite over hypotenuse. So the opposite must be 12. The hypotenuse must be 13. So then what is the missing side? Well, Pythagorean theorem, x squared plus 12 squared equals 13 squared. So x squared plus 144 equals 169. Subtract 144, and I get 25. So x is 5. But when we look at that picture, 5 seems like the right measurement, but remember in the last lesson we talked about how direction is important, and that x is going to the left, so that needs to be a negative 5. So we have to be careful of our positives and negatives. That's why it matters what quadrant we're doing this in, is because of those positives and negatives. So this x is actually a negative 5. Now we are ready to do our SOHCAHTOA. Cosine is adjacent over hypotenuse. We just found that adjacent is negative 5, and the hypotenuse is 13. Okay. We'll do one more. So in this one, we're going to put our angle in quadrant 3. We're going to say that our cosine this time is equal to negative 1/4. And we want to find sine of the angle. All right, so let's start by drawing our picture. Quadrant 1, 2, 3. So draw a triangle, connect to the x-axis. Theta goes next to the origin. Cosine in this triangle, cosine is adjacent over hypotenuse. So this time the adjacent is negative 1 and the hypotenuse is 4. Now just to think about that negative, I wrote it as negative 1/4, but the problem could also have said cosine of theta is negative 1/4. And then you might wonder, well, where do we attach that negative? Does it go to the top? Does it go to the bottom? Does it go to both? So remember from the last lesson, a hypotenuse is always positive, no matter what. So in this picture, we want to make sure that hypotenuse of 4 is positive. The adjacent, it makes sense that it's negative 1 because it's going to the left on the x-axis. So we can assign that negative based on the picture more so than based on where the negative is in the fraction. All right, so now we're ready to find the missing side of this triangle. So we want to find, this time I'm going to call it y because it's a y measurement, like the y-axis. You could call it x if you want, just because algebra we often call missing things x, but really visually what we're finding is a y value here. So I'm going to do negative 1 squared, make sure you use parentheses, plus y squared equals 4 squared. We need those parentheses because negative 1 being squared gives a positive 1. If you don't do the parentheses, it's going to give you negative 1, and then you're going to get your next answer wrong. And 4 squared is 16. Subtract 1 from both sides. Y squared is 15. And y is a square root of 15 because that doesn't work out nicely. So the other ones it worked out to be a nice perfect square. This one, it doesn't. So we're just going to say that it is a square root of 15. Then think about your up, down, left, right. That y is below, so that's a negative square root of 15. After that's all labeled, then we can think about our SOHCAHTOA. We're trying to find sine, so we're trying to find an opposite over hypotenuse. The opposite of theta is that negative square root of 15. And the hypotenuse is 4. Okay. All right, that is all for today's lesson. So I know the last lesson was pretty long. This one was quite a bit shorter, but still tricky stuff. So as you're working, make sure that you ask me questions, and I'm happy to help. See you again soon.